Here we are in the 4-lane calculator. We started up with a blank screen. You can see untitled, there's no vehicle described. There's two ways to start building a new vehicle. You can start from scratch, which would happen if you clicked on File and New, or you could click on Open and open some existing vehicle file and then just make the modifications necessary. But let's say we're going to cancel out of this and we're going to start from scratch. How you do that is you click on your measurements. You're going to describe each bracket and the holes in each bracket. Let's say this hole, this bracket, the top axle bracket on the axle has 4 holes, and we're going to describe each hole here in dimensions. How far ahead of the axle? That would be how far ahead of the center line of the axle right here is it? Let's say this first hole is 2 inches ahead, and that hole is 10 inches above the ground. And you can see over here that hole is drawn. We'll go through here and I'll just do this fast, making up some arbitrary numbers. And you can see over here we're going to enter the distance above ground. And you can see here in blue, that's the hole that's being used. You say up here we're using hole number 1. So that's why that one's highlighted in blue and is drawn in blue. And here are the other holes. Now I just thought I've drawn holes that are probably make more sense for the lower bracket. Obviously if you're measuring this, it'll all be right. But I can show you how you can quickly adjust all of these measurements by over in this box. Let's say I made a mistake and all of these measurements are, let's say, 6 inches too low, and we want to move them up. Move all existing holes up 6 inches. And you can see the drawing is redrawn, and now here they are there. Maybe we want to, this time we want to still move it up 3 more inches, and we do it again. So that's how you put in your brackets. Okay, so let's assume that we've done all those measurements for the 4 brackets. And there's still this additional screen, and you can see we haven't drawn a car yet because there's still some critical information for at least being able to draw the car. So you click on other car measurements, and these are pretty critical, and these are important at least to be able to draw the car. The wheelbase, well, let's say it's 105, that's the distance separating the front and rear tires. Height of the center of gravity. This is something that people get all too concerned about. You're not going to know the height of the center of gravity. You could click on this calc button here and measure it by raising one end of the car and seeing how the weight changes. Measure the weights on as the car sits level, and then measure the weights again as you've raised one end of the car, maybe 20 inches. If you're super precise, you can do this. Most of the time, though, you're not going to be able to do this precise enough to get a good number. For example, being off 2 or 3 pounds can change the height of the center of gravity 5-10 inches. A good estimate for the height of center of gravity, not knowing anything, is given right here in these help boxes down here. That it's about 5 inches above the crankshaft height. Usually ends up being between 14 and 22 inches off the ground for most cars. If your engine is lowered, like it is in this one that we're doing here, the crankshaft height is about 15 inches. So 5 inches above that would be 20 inches for the height of center of gravity. This is not super critical. It just helps us calculate the percent anti-squat. And what we're looking for is trends here, if we're going up or down in the percent anti-squat. So this estimate is good enough. Percent weight on the rear can be calculated by knowing the front weight and the rear weight and using this little calculation menu here. So let's say the total weight on this car is 2,200 pounds. And then when you weigh just the front axle, the front 2 tires, it ends up being 1,050. And that was by measuring just the front. It comes up with the percent weight on the rear is 52.3. We're going to use that number. This stuff is only important for drawing stuff. these angles down here. But let's say we got these angles. Yep, that's should be a -3. And you can see this little drawing here is giving you an idea how these angles are going. And then the trans yoke angle, yep, should be a -4. Most production engines have about a -4 degree trans yoke angle. Here's your front and rear tire diameter. Your vehicle's weight, and we said in that other screen is 2,200 pounds. And the approximate quarter-mile ET that you're running happens to be about 9.3 seconds. And this only has to do with this color, only has to do with how the car, what color you want the car drawn in. So after you got those specs typed in, now you can see, now we do get a car drawn. And here you can see, here's our hole locations here and here. And if you want to zoom in on some of this stuff, you can see we got a nice little deal here. You can zoom in and really look, move things around to see where these holes are. Let's turn off zoom, go back, and use two important options here. Do you want to show all the instance centers, or do you want to show just one instance center for the current location or current instance center for the holes you've chosen for these brackets, and allow some dynamics? Dynamics means going through some squat and rise and see how the instance center is moving. Most people are going to use this first one, show all the instance centers. And here they are, these little crosses are all the different instance centers for all the combinations, and you can change them. And you can see we've changed it up here as we change them. Now watch when I click on this. You can see that this lower arm got changed. And another important option, because you're going to want, if you're not sure what you're looking for, is Dave Morgan suggestions. Dave Morgan is a very noted chassis tuner, written books on it. And this green box here is based on the car's estimate of ET that you're going to run and its weight, which basically is going to determine its horsepower also. And Dave Morgan would say, knowing nothing else about your car, try and use an instance center that's in this box or at least close to this box. And another thing, you'd say, well, that box is very high and low. Do you want one down here, or do you want one that's way up here? Well, it depends on this neutral line here. This neutral line here is, and you can turn that on and off. Don't show the neutral line, and now it's not there. Or show the neutral line. And the neutral line is all instance centers that fall close to this line, this slope dotted line, give 100% anti-squat. 100% anti-squat means the car will neither, the back end will neither rise nor squat during acceleration. It's anti-squat 100%, it won't happen. If you got more than 100% anti-squat, that is instance centers that fall above this line, the back end will actually rise as the rear tire and the axle is trying to be driven underneath the car. If you got instance centers down here below the neutral line, like these, the car will actually squat, which is what you typically expect a car to do, but it will squat. So if it's close to this line, it's 100% anti-squat. There's nothing magic about 100% anti-squat, but it does seem like a good starting point would be 100% anti-squat to 130% anti-squat, somewhere at this line or a little above in this green box. So here, what do we have here? This one's kind of low that's in the box. This instance center here looks pretty good. And which one is that? We click on the crosshatch for that instance center, and you can see the holes have been picked for that instance center right here. Those are the holes that produce something in the green box, which is the length of the instance center, and roughly about 100% anti-squat. And the anti-squat number is given up here, 99.9. You can't get much closer than that. So if knowing nothing else about this car, this would be a good starting point for your first setup. If you want to go with more anti-squat, you're going to go to some of these other, like this one here, which is above the neutral line. Or if you want less anti-squat, That is, you don't want to hit the tires as hard. You go to maybe this one here, which is a little bit less than 100% anti-squat. It's about 88.3%. But it's still relatively close to Dave Morgan's suggestion in this box. If you want to do some dynamics, click on Options. Just show one instant center. Another option you might want to do is you want to show the extension lines. Here's the links, and the extension lines are showing where that how that instant center is drawn by projecting these two arms forward and seeing where their lines intersect. And if we turn on dynamics, we can have the car go through some compression in the rear, and you can see that the instant center is only going down. Down means that it's going to lower anti-squats, which means as soon as you start to compress the rear springs, that you're going to be losing your anti-squat. May not be what you want to do. And you can see here the trans-yoke movement, how the pinion angle is changing, how the drive shaft angle is changing. Trans-yoke movement is how much is the yoke sliding into the transmission. Minus means it's actually sliding out of the transmission. So here we have covered a lot of the features of the 4-link calculator.